Okay, and so today we are looking at Venn diagrams. Okay, so in the question here we're told that U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, so that's our universal set. And within that we have A equal to 3, 5, 7, 9, B equal to 1, 2, 3, 4, 5. And so we have to represent this on a Venn diagram is the first part of the question. So I'm going to begin by drawing a rectangle, and that rectangle is U to represent our universe. Okay, and so here I write down U and I say hashtag U, and we remember that hashtag means the cardinal number. So the number of elements in U, well, we can see it there, very straightforward. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in U this time. Okay, and then inside in our universe we have two sets. We have A and B, and they are two interlocking circles. Now before I go any further, here I go and I look and I see, is there any elements that are in common between A and B? And I see here there's a 3, so I'm going to mark that in here into the middle because it's in both sets. So there's 3, and I cross it out from both of those sets. I also see that here there's a 5 and here there's a 5, so that also goes into the middle. So 5 and 5. And now not only do I cross them out from A and B, I also cross them out from U because they've just been used there. So the remainder in A is, well, 7 and 9, and the remainder in B is 1, 2 and 4. So now I go back, I cross those out, but I also cross them out here from U. Likewise, I cross out 1 from B, 1 is crossed out from U. I cross out 2 here and 2 there, and 4 and 4. And I can see up here in U, there's 6 and 8 left. So they don't go into A and they don't go into B, so they have to go out here in outer space. This space is still in the universe, but not in any other set. So 6 and 8. So that's ours represented on a Venn diagram. Okay, and so now that we have our Venn diagram completed over here, our job now is just to answer the following questions. So the first part there, part 2, asks us what A union B is, to list the elements in A union B. So I write A union B, I draw my curly bracket, and then I know that A union B is any of this bit here in the middle, and this bit here in B only. And so I write down exactly what I see. So 7, 9, 3, 5, 1, 2 and 4, and then I'm just going to reorder them so that they're in numerical order. So that's 1, 2, 3, 4, 5, 7 and 9, and that's A union B. Okay, the next bit then asks me to find A intersection B. So let's have a look at A intersection B. I'll just move this over here. So A intersection B, part 3. And I have this here, my symbol for it, and again my curly bracket. And I know that A intersection B is just this bit here in the middle where the two sets overlap. So very straightforward. That's just 3 and 5. So they're the bits that are in both sets, in both A and in B. Okay. Next bit then we have is part 4, and part 4 asks us what is the cardinal number, hashtag A union B. And so again we just count here. So how many elements are in this? Well, we've 1, 2, 3, 4, 5, 6, 7. So it equals to 7. Or I could have looked up here and saw that it's 1, 2, 3, 4, 5, 6, 7. So either way, I know that the cardinal number, the number of elements in A union B, is equal to 7. Next part, part 5, asks me what is the cardinal number, of A intersection B. So that's how many elements are in the intersection. Well, it's just 3 and 5, these two here, so we have 2 elements. So pause the video here and make sure that you have all of these notes taken down as we've gone through them. We're going to move on now to the next 3 parts of the question, but this is new information to us. So before we answer the questions, we want to look at these symbols. So here in part 6, we're asked to list the elements of A / B. So this / symbol, it's a new symbol to us, and it means without. So it's like the bit that's in A only. So if I was to draw a Venn diagram and just to shade in the bit that represents, I'd have A here, I'd have B here, and A without B is just going to be this bit here. Okay? And similarly, B without A would just be equal to this bit, just in B. So B only would be this bit here. Okay? So that / symbol means without. So make sure to get those notes in your copy, as that's something new to us today. Okay, and so we'll look and we'll see, well, what is A without B? So part 6, here we go. A / B, or A without B. Well, that's just this area here, this part of A. So again, we can see there's only 2 elements. So it's the bit that's in A only. So it's 7 and 9. Similarly, if I look and list the elements of B without A, well, I can see here, B without A is this part here. Okay, so where there's no overlap. So it's just this bit here. So it's going to be the elements 1, 2, and 4. Okay, and then lastly, then we're looking for the elements of A dash or A complement. So we've looked at this symbol before, so A dash or A complement. And just if I was to draw that image here just as a refresher first, that's A, that's B. So this is, well, it's everything that's not in B, not in A, sorry. So it's all of this bit here, but also, what else is not in A? All this bit out here in outer space. Okay? So that's all of A complement. So let's get that image drawn into our copies as well, and then let's answer the question. So here we have the last part, part 8, and it asks us to list the elements of A complement. So here we have, well, I have 1, 2, 4. I also have, what's in outer space there? 6 and 8. 5 elements. So these bits here aren't in A, and these bits out here. Okay, so let's make sure that we get all those notes into our copy, that we have a refresh on our new symbols, our new language. So A / B means A without B, and here the dash meaning A complement, everything that's not in A. And we'll move on to the next question then.